NCM Learning Center.
Good morning friends. In this video we are going to discuss about how to find the efficiency of the DC machine and the problems from these topics. Already we discussed in the previous video, in the part 1 videos we discussed the first 3 topics. What is lap and winding concepts and the induced back equations concepts, torque equation concepts. In the part 2 videos we discussed the types of DC motors and generator concepts and the problems from the topics. Then in this video we are going to discuss about the efficiency calculations of DC machine, DC motor and DC generator. In the next videos we will discuss the remaining topics one by one. Okay, now we will discuss what is efficiency. Efficiency is defined as the ratio of output by input. So for the calculation of efficiency we need output and input. If you know the output and input, we can find the efficiency. For DC motors we know that for DC motors input is electrical power, output is mechanical power. Output is rotation. So electrical power is easily measurable, voltage into current. So input P in is equal to V into I. So input power is easily measurable, voltage and current. By using voltmeter and ammeter we can measure. For the shunt motor, here this input is voltage, here current, this is input current. This armature current is shunt field winding current. So P in is equal to V into I. For motors the input is easily measurable. If you know this armature current and shunt field current, we can easily find the input current. Okay, but output is not an easily measurable one. So output is equal to input minus losses. Basically input is given, there is some losses, maybe heat loss or some losses, then we will get the output. So output is equal to input minus losses. If you know this losses value and input value, we can find the output. Then we can find the efficiency. For DC generator, we know that output is electrical power, input is mechanical power. So we can easily measure the output value. So P out is equal to load voltage, output voltage into load current IL. For example, DC generator, here EF is induced in the armature. Here output voltage is, this is V is load voltage, output voltage, so IL is load current. So P out is equal to load voltage in load current. Here output is easily known, but we have to find the input. So input is equal to output plus losses. If you know the losses value and output, we can find the input for DC generator. If you know this output and input, we can find the efficiency. Okay. Commonly for loss calculations in the DC machine, commonly there is a two types of losses. The total losses is equal to constant loss and variable loss. The constant loss is fixed loss, it will not vary, but the variable loss, it will vary with respect to load. So the constant loss is another name for the constant loss is iron loss or stray loss. So we can represent this loss is equal to PIR, iron loss. There is two types of constant loss. One is hysteresis loss and eddy current loss. This combined loss is called as iron loss. If you know the hysteresis loss and eddy current loss, if you add, you will get the iron loss. These are constant loss. Another one is variable loss. Variable loss is another name is copper loss, because this loss takes due to the copper winding, armature winding and field winding. It is represented as PCU, copper loss. Copper loss takes place due to the armature winding and field winding. So the combined armature winding loss and field winding loss is the copper loss, total copper loss. So the armature winding loss, the armature current flows through the armature winding, so the loss is Ia square RA. Then field winding loss. for some type of DC machines. For example, DC shunt machine, shunt winding only is there. For the DC series machine, series winding only there. But in the compound machine, they have both series and shunt winding. So the field winding loss is the combined form of shunt and series winding. For the shunt machine, it have only shunt, so IS square RS square. For the DC series machine, it have only series current. But the compound machine, they have both. So it is represented as PCUF. So total copper loss PCU is equal to PCUA plus PCUF. Okay. Then the no load power. The other important point is the total loss is equal to no load power. Under no load condition, it takes some power. That power is the total loss. That value is equal to total loss. This represents as P loss. Note that the iron loss does not vary with load changes. This is the concepts. Now we will discuss the problems. Here, this is shunt motor is given. It takes 10 amps under no load condition. 250 volt is input voltage. The armature resistance and field resistance is given. What is the efficiency of the machine? It acts as a generator delivering 10 kilowatt at rated voltage. Okay. We know that efficiency formula, efficiency is equal to output by input. For the DC generator, we know that output is electrical power. We know that, but input is a mechanical power. So input is equal to output plus losses. So to calculate the efficiency of this generator, we need output and losses. So here output is given. Output of the generator, P output of the generator is 10 kilowatt. So 10 into 10 power 3. Here output is given. So only we got to find the losses. Our objective is to find the P loss, total loss of the generator. We know that total loss is equal to constant loss and variable loss. Constant loss is PIR, variable loss is copper loss PCU. Okay, the copper loss PCU is equal to sum of armature winding loss and field winding loss. Okay. We will calculate the P loss of generator. First we will calculate the iron loss of the generator. Iron loss, we know that iron loss does not vary with load. So iron loss of motor is equal to iron loss of generator. Here same type of windings, the same machine act as a generator. Okay, so the iron loss of generator is equal to iron loss of motor here, because same machine acts as both motor and generator. Okay, that is why the iron loss of generator is equal to iron loss of motor. The constant loss does not vary with load. So now we will find the iron loss of motor. Here no load power is given, no load voltage, no load current is given. So no load power is, we can find the no load power. So no load power is equal to total loss of motor. So total loss of motor is given. Total loss of motor is equal to 250 into current, V into I, 250 into current 10, so 2500 watts. P loss value is given. P loss of motor is known. If we find the PCU, copper loss of motor, we can find the iron loss of motor. Now we will calculate the copper loss of motor. So here shunt motor is given. We know the equivalent diagram of shunt machine. This is shunt machine. Here input voltage 250 volt is given, and the armature resistance 1 ohm is given. Field resistance 120 ohm is given. It takes 10 amps under no load condition. So for the calculation of copper loss, we got to find the copper winding loss. We need IA and we need ISH. For the calculation of IA and ISH, we can find this ISH value here. This is parallel. This current is ISH current. This current is field winding current is IS gauge current. So IS gauge is equal to here voltage 250 divided by current resistance 125. This is in parallel. So just apply just voltage law. This loop will get IS gauge is equal to 250 divided by 125. V is equal to IR. V is 250. I is IS gauge. Here RS gauge value is 125. So IS gauge value is 2 amps. If you know this I and IS gauge, we can find IA. Just apply current law at this junction will get total current I is equal to IA plus IS gauge. From that IA is equal to I minus IS gauge. So 10 minus 2, 8 amps. Now we can easily find the copper loss, armature winding copper loss. This is armature winding copper loss of motor, not generator. So IA square RA, here IA value is 8, RA value is 1 ohm, so we will get 64 watts. A copper loss of field winding copper loss of motor loss, PCF of motor. The shunt motor only have a shunt winding, so IS square RS gauge. Here IS gauge value is 2 amps, substitute here 2 square RS gauge value is 125, so we will get 500 watts. So the total copper loss of motor is equal to copper loss of armature and copper loss of field will get 564 watts. Here total loss is known, copper loss is known, from that we can find iron loss. Substitute here P iron loss of motor is equal to P loss of motor minus copper loss of motor. So we will get iron loss of motor is equal to 1936 watts. Okay, same type of machine. So iron loss of motor is equal to iron loss of generator. So we will get iron loss of generator is equal to 1936 watts. Next we go to find the copper loss of generator. If you know the copper loss of generator, we can find the total loss of generator. Okay, we know the equivalent circuit diagram of for the generator. This is equivalent circuit diagram for the generator. The only difference is current. Here EMF induced in this armature, there is current flow out from the armature. This is load current. Okay, then here the power output power is given. Output power is 10 kilowatt. Output voltage is known, output power is known. So we can find the output current IL. IL is equal to power by voltage. Power P is equal to voltage into current. From that current is equal to power by voltage. So power is 10 kilowatt. That is why 10 into power 3. Voltage is 250 volt. So total current, load current is 40 amps. By applying this voltage in this loop, we can find the IS gauge. For shunt machine, field current is constant, or otherwise just apply the voltage here. So we will get IS gauge value is equal to 255, 125 is equal to 2 amps. This shunt current is constant one. Okay, P by I, P by R is equal to I. Now here IL is known, IS gauge is known. From there you can find IA. Just apply this current like this loop in the junction, we will get IA is equal to IL plus IS gauge. So we will get IA is equal to 42 amps. Now find the copper loss of armature. IA square RA, just substitute here, we will get 42 square is equal to 1764 watts. Now find the field winding loss, PCF of generator. IS square RS gauge, here IS gauge value is 2 amps, so we will get 500 watts. Now the total copper loss of generator is equal to PCU is equal to 2264 watts. This combined form of armature and field winding. So we will get 2264 watts. Now the iron loss of the generator is known, copper loss of the generator is known. So we can easily find the total loss of the generator. P loss is equal to sum of this both. So we will get 4200 watts. Output is known, losses is known, so we can find the efficiency easily. So efficiency of the machines, output is equal to 10 power 3. So 10 power 4 divided by 10 power 4 plus loss value 4200. Efficiency is equal to 70.4%. So option C is correct. Okay, this is the concepts. Now another important point is the condition for maximum efficiency. At what condition the efficiency will be maximum? Remember that when the constant loss is equal to variable loss, the efficiency of the machine will be a maximum. Remember this point, okay? So now do it yourself. This question is asked in gate 16 examinations. Here some generator is given, it delivers 45 amps, load current is known, load voltage is given, so we can find the load power. Here armature resistance, field resistance is given, stray loss, constant loss is given, okay. So directly we can find the variable loss, and the here generator output, find the output, we can find the efficiency of the machine. The answer for the question is 86.8%, okay. If you have mismatch your answers, just comment your answers. If you have any doubt related to the discussion, just post your doubts in our WhatsApp group. Definitely you can get the clarification, okay. Continuously watch our channel, definitely you can get the good marks in the competitive examinations. Good, thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.